Hello, everybody. Welcome into another lesson, and happy Easter to everybody who's watching. I hope it was a good one for you, or is a good one. So, today we are going to talk about ratios. Ratios are just a comparison of two different units using division. So, for example, let's say we have 6 ladybugs. Right, so we got 6 ladybugs to 27 insects. Right, 6 ladybugs to 27 insects, okay? Well, you may see it written as 6 to 27. You may see it written as 6 colon 27. Or most commonly, you'll see it written as 6 over 27. This is the format we're largely going to use, our fractional. We're largely going to dive into the fractional side of that. So, let's do the fraction 6 over 27. Well, since it's a fraction, we want to simplify it. 6 and 27 have a common 3 that will divide between them. So 6 divided by 3 is 2. 27 divided by 3 is 9. So the real ratio is going to be 2 to 9. It'll be 2 ladybugs for every 9 insects. Alright. Next, we could say we have 14 girls to 35 boys. So we got 14 girls to 35 boys. So that's in the ratio of 14 over 35. Well, we can clearly simplify 14 and 35. They both have a common factor of 7. 14 divided by 7 is 2. 35 divided by 7, well, that's going to be 5. So the real ratio is 2 to 5. It's 2 girls for every 5 boys. So basically, you're going to treat these ratios like you would a fraction, because after all, it is actually a fraction. It's just a different way of going about it. Or you could say something like 12 roses out of 28 flowers. Alright, so we got 12 roses out of 28 flowers. Well, so that'd be 12 over 28. That's 12 out of 28. Well, clearly 12 and 28 have a common factor. They both have a common factor of 4. If you divide 12 by 4, you get 3. You divide 28 by 4, you get 7. So the ratio is really 3 to 7. It's 3 roses for every 7 flowers. Alright, so that's basic ratio format. Now, we're going to dive into another type of ratio called a unit rate. And the greatest example of unit rate is when you want to find the price per 1 unit of something. So, let's say, for example, it's $5 for 4 cans of tuna. $5 for 4 cans of tuna, right? Okay, well, that would be in the ratio of $5 to 4. $5 for 4 cans. That's what the ratio would be. If you want to find, of course, our goal is to find the unit rate, which that means find the rate for 1 can. Well, if we want to find the rate for 1 can, we got to divide both numerator and denominator by 4. If we divide 4 cans by 4, you'll get 1 can. 4 divided by 4 is 1, but you got to do it to the numerator also. $5 divided by 4, well, that happens to be $1.25. So yes, it is $1.25 per can. That would be the unit rate. Or yeah, the unit rate, the unit price. It'd be $1.25 per can. So that's a very big example in the real world of using ratios to find unit rates, unit prices. Alright, or let's say another one. You have 99 cents for 10 pencils. So yes, 99 cents for 10 pencils. So that'll be in the ratio of 99 cents for 10 pencils. Alright, well, we have the rate for 10 pencils. We want to find the rate for 1 pencil. Well, if we want to find for 1 pencil, we got to divide the denominator by 10. 10 divided by 10 is 1, so you get the price for 1 pencil. So that means you also got to do it to the numerator. You divide the 99 cents by 10. What you're actually going to have is a pretty hideous figure here. It'll be 0.099, which is approximately equal to, we know it doesn't break down into thousandths of cents. It would just round up to the next cent. So that'd be approximately equal to 10 cents per pencil. So that'd be 10 cents a pencil, approximately. That's what you would get. I've never seen a thousandth of a cent piece. A thousandth of a dollar, rather. So they just round to the next cent. Another big one is gas mileage. So we can go 140 miles on 6 gallons. So someone goes 140 miles on 6 gallons. We want to find how many miles they'll get for 1 gallon. So what you're going to have to do is divide both the numerator and denominator by 6. Divide the denominator by 6, you'll just get 1 gallon. Now we got to divide 140 divided by 6. We got to do 140 divided by 6 here. That's about 23 approximately. It's really 23.3 repeating. That's when you would say approximately 23 miles per gallon. So I would say that would round to about 23 miles a gallon is what you would get. So gas mileage, as you know, anyone who drives knows that's a very big unit rate ratio is gas mileage. Alright. So let's see. If something goes 68 meters in 15 seconds, so that's going to be in the ratio of 68 meters to 15 seconds. Ideally, the goal would be to find how far it goes in 1 second. So in order to figure out how far it goes in 1 second, of course, divide the denominator of 15 seconds by 15, you'll get your 1 second. But since you did that to the denominator, you got to do it to the numerator. So we got to find 68 divided by 15, which is probably not going to be a pretty number. Nope, it's 4.53 repeating meters. So you could probably round this to the nearest tenth and say approximately 4.5 meters in 1 second. So yeah, the rate is about 4.5 meters per second. Alright. So really it's up to you or your teacher, however many places they want you to round in these scenarios. Personally, for me, I'd say to the nearest tenth. That's why I came up with 4.5 there. I figure it's a lot easier to express it as 4.5 meters a second than 4.53 repeating meters per second. Alright, we have something going 19 yards. So something is going 19 yards in 2.5 minutes. So something goes 19 yards in 2.5 minutes. So that's going to be in the ratio 19 yards to 2.5 minutes. Alright, so we know it goes 19 yards in 2.5 minutes. We'd like to know how far it goes in 1 minute. In order to find that out, to get your unit rate, you're going to divide both numerator and denominator by 2.5. Divide 2.5 by 2.5, you get 1. You'll have 1 minute. Now you just need to divide that 19 by 2.5. 19 divided by 2.5 comes to 7.6. Exactly 7.6. So it'll go 7.6 yards per minute. That's the rate it's going. That's the unit rate. 7.6 yards per minute. How many more do we got here? Oh, we only got 3 more. Alright, here's something. 25 feet in 3.2 hours. Well, that seems pretty slow to me. Something goes 25 feet in 3.2 hours. That seems pretty dang slow. But nonetheless, that'll be in the ratio of 25 feet over 3.2 hours. Alright, so we have 25 feet over 3.2 hours. We know how far it goes in 3.2 hours. We'd like to know how far it goes in 1 hour. In order to do that, you'll have to divide the denominator by 3.2, which would give you 1 hour. But you also got to do it to the numerator since you did it to the denominator. So let's go ahead. Let's divide 25 by 3.2. 7.8125. It's exactly 7.8125 feet. I think we should round to the nearest tenth. It'll go 7.8. So it's approximately equal to 7.8 feet in 1 hour. Or per hour. You don't even have to have that 1 there. It's just 7.8 feet per hour. So, yeah, that's moving at about a snail's pace, I would say. Two more. Go 236.7 miles. In 4.5 days. So, this also, you probably have to be riding a horse or driving a horse and buggy or something across the country to go that rate. or walking across the country. Even then, that'd be quite remarkable if you were walking. But this is another snail's pace. You have something going 236.7 miles in 4.5 days. So we know that this is, whatever this is going 236.7 miles in 4.5 days. We'd like to know how far it's going in one day. So to figure out how far it's going in one day, you'll divide 4.5 in the denominator by 4.5. You'll get 1 day. But that means you have to divide that 236.7 miles by 4.5. So 236.7 divided by 4.5, that's 52.6 miles. Exactly 52.6 miles in a day. So yes, whatever this is moving at a rate of 52.6 miles per day. Can't be a car, that'd be the slowest car I ever saw. So that's your unit rate, 52.6 miles per day. That'd have to be maybe on a horse and buggy. Last one here. See, 331.5 pages. In 8.5 weeks. Now, if that's your rate of reading, you're not reading very much, I can tell you that. So, we'll say someone's read or is reading an average rate of 331.5 pages over a time span of 8.5 weeks. Well, we'd like to know, we know how much they've read in 8.5 weeks. How much are they reading in 1 week? Well, in order to figure that out, you're going to have to divide the denominator by 8.5. You'll get 1 week. But since you did it to the denominator, you got to do that to the numerator. So let's do 331.5 divided by 8.5. Get exactly 39. That's exactly 39 pages in 1 week. So this person is reading at a rate of 39 pages per week. Sounds like they need to pick up the pace a bit. 39 pages a week, that's not very much at all. Okay, so unit ratios, again, just comparing two quantities of different units. You express it as a fraction. Usually the first number given is the numerator. The second number is usually the denominator. Unit rates, you want to figure out what would make the denominator 1. You want to do, of course, to the numerator. You'll get the rate per 1 unit. As opposed to so many units, you'll get the rate for 1 unit. That's the idea of a unit rate or a unit price or what have you. So that's it for ratios. Next lesson we will talk about proportional relationships, what it means for something to be in proportion or not in proportion. I hope everyone has a good Easter. Take care.